This lesson is about measuring to find the area of rectangles with fractional side lengths. And then what they have you do after you find the side lengths, after you've measured it, they have you calculate it. But since this is a video, it's not going to work well to have you measure it. So I want to make sure that we can know how to go over the different shapes and possibilities within rectangles to find those areas. So look at this first one, where we have 2 inches by 2.5 inches. So I'd like you to find the area of this, and I want you to try doing that using the area model that we talked about yesterday. And if you're not sure, go ahead and solve the area another way, and then I'll show you the area model in a moment. Okay, the first thing that I did when I started to solve this is I flipped it because I want to be able to expand higher up later on. And then I'm drawing my lines so that I can have 1 inch here and 2 inches here. And then I'll have 1 inch below, 2 inches above, and then I have this 1/2 inch area. And what you don't really see is that we have this third section up here, which would give us 3 holes. Okay, and then I can shade in the area for each part. So for 2 inches, I'm going to shade in the entire thing with one color, representing that I have 2 entire pieces there. And then what I'm going to do is I'm going to shade in 2.5. Okay, and what this represents is the 2.5 going horizontally. Notice that I did not shade anything in this half up here. And then I can count up what I have. And when we do that, we see that I have 1 hole here. Oh, that's hard to see. Let's make it another color. Okay, we have 1 hole in this bottom part. We have another hole here. So we have 1 plus 1. And then we have another hole here and another hole here. And we have a 1/2 here and a 1/2 here, which we are then able to add all these together to get 2 plus 2 plus 1, which gives us 5 as our area. Now we need to be careful because these aren't just halves up at the top. Really what we're doing is we have this imaginary line going down the middle, splitting it into quarters. Okay, so we skipped a step when I solved it and said that we have 2 quarters, which is 1/2. So be careful when you're doing that. This is what it might look like if you solved it on graph paper. Again, we have 1, 2 at the bottom and 2.5 up at the top, where I did add on that initial part. And what I did with the shading is I did green to show my 2 holes, and then I did purple to show 2.5. And with the graph paper, it's nice because you can actually count the individual squares inside 1 hole. And if you're in my class using this, I have graph paper that you can use. Try one more problem and see if you can find the area of this shape on the inside of the figure. Do not count the squares because I did not draw it to scale with the numbers. So the square has each side that's 9.25, and it has a 2.5 unit square cut out from the inside. Lots of different ways to solve this. Try one of the different ways. Okay, first thing that we did is we did our area formula where we have length times width, which is 9.25 times 9.25, which is going to give you the area of this entire square, which is 85 and 9/16 square units. But I haven't taken out this little piece yet, so then I need to do the area again, and again I'm going to write that formula and solve for that, which will give me 6.25, and then I can do 85 and 9/16 minus 6.25, and remember that 1/4 is the same as 4/16. So then I can see that that area is 79 and 5/16, and that's unit squared. So the way that I did it is I found this area first for the entire thing, and then I cut out that piece. Okay, maybe you found the area of the top rectangle, and then the middle rectangle, and the bottom rectangle, and then added those together. That's another option. Okay, there are multiple ways to do it. Just make sure that you understand what you're doing and why, and that you are able to explain it.